Addressing a situation involving non-metallic raceways under a building where an inspection was missed before the slab was poured requires a strategic approach. Several options are available to rectify the situation without necessarily resorting to digging up the slab. Firstly, contacting the authority having jurisdiction, or OJ, is paramount. Explain the situation transparently, acknowledge the oversight, and propose a solution that aligns with code requirements. Emphasize the documentation available, such as compaction tests, photographs taken during the installation process, and engineer field reports generated before the slab was poured. This documentation can serve as evidence of compliance with relevant standards and practices. Secondly, consider requesting a code variance from the AHJ. This involves submitting a formal request outlining the specific code requirements from which a variance is sought. Provide all supporting documentation, including the compaction tests, photographs, and engineer reports. Clearly explain the hardship or practical difficulty that would result from strict compliance with the code. The AHJ may grant a variance if it determines that the proposed solution meets the intent of the code and does not compromise safety. Thirdly, submit a request for inspection, or RFI, to the AHJ. In this request, explain that the pipes were inadvertently backfilled before inspection and provide the aforementioned documentation as evidence of compliance with applicable standards. Request a re-inspection based on the provided documentation and any other relevant information. The AHJ may conduct a re-inspection to verify compliance or request additional information. Fourthly, hiring a third-party inspector is another viable option. Engage a licensed electrical inspector who is qualified to verify compliance with the National Electrical Code and local electrical codes. This inspector can conduct an independent assessment of the installation and issue a certificate of compliance if it meets the required standards. This certificate can then be submitted to the AHJ as evidence of compliance. Fifthly, non-destructive testing, or NDT, methods can be employed to inspect the buried conduits without the need for excavation. Techniques such as ground-penetrating radar, or GPR, and infrared thermography can provide valuable insights into the condition and placement of the conduits. GPR uses radar pulses to image the subsurface, allowing for the detection of buried objects, including conduits. Infrared thermography detects variations in surface temperature, which can indicate the presence of thermal anomalies associated with the conduits. These NDT methods can help assess the integrity of the installation and identify any potential issues. In addition to these options, implementing mitigation measures is essential to ensure the long-term reliability and safety of the electrical system. One important step is to thoroughly document the current state of the installation. Take detailed notes and photographs to record the placement of the conduits, the type of materials used, and any other relevant information. This documentation will serve as a valuable reference for future maintenance and troubleshooting. Furthermore, take steps to protect the buried conduits from damage. This may involve adding additional cover to provide physical protection or installing conduit markers to indicate the location of the conduits. Proper protection can help prevent damage from future construction activities or other potential hazards. Regularly monitor the electrical system for any signs of issues that could be related to the buried conduits. Check for any unusual voltage drops, circuit breaker trips, or other anomalies that may indicate a problem. If any issues are detected, investigate them promptly and take corrective action as needed. In all interactions with the AHJ, it is crucial to communicate effectively. Be transparent and provide all relevant information in a clear and concise manner. Respond promptly to any requests for information and be prepared to answer any questions that the AHJ may have. Maintain a professional and cooperative attitude throughout the process. Respect the AHJ authority and work collaboratively to find a solution that meets the code requirements and ensures the safety of the electrical system. To prevent similar issues from occurring in the future, it is essential to learn from this mistake. Review the reasons behind the violation and identify any weaknesses in the processes or procedures. Implement corrective actions to address these weaknesses and ensure that all future installations are inspected before backfilling. This may involve providing additional training to personnel, implementing checklists to ensure that all required steps are followed, or improving communication between different teams involved in the construction process. When dealing with electrical installations and compliance with the National Electrical Code, several key considerations should be kept in mind. Understanding the relevant sections of the NEC is crucial for ensuring that installations meet the required safety standards. Table 300.5 specifically addresses the minimum cover requirements for direct buried cables and raceways. The depth of burial depends on several factors, including the voltage of the circuit, the type of raceway, and the location of the installation. For example, for residential branch circuits rated at 120 volts or 240 volts, a minimum cover depth of 12 inches is typically required for non-metallic raceways. However, this depth may vary depending on the specific circumstances. It is essential to consult the latest edition of the NEC and any local amendments to determine the applicable requirements for a given installation. The type of raceway used also plays a significant role in determining the burial depth. Rigid metal conduit, or RMC, and intermediate metal conduit, or INC, typically require less cover than non-metallic raceways, such as electrical non-metallic tubing, or N, or rigid polyvinyl chloride conduit, or PVC. This is because metal conduits provide better physical protection for the conductors. The location of the installation is another important factor to consider. Installations under roadways or in areas subject to heavy vehicular traffic typically require greater burial depths to protect the raceways from damage. Similarly, installations in rocky or unstable soil may require additional protection to prevent damage from shifting or settling. In addition to the minimum cover requirements, the NEC also specifies requirements for the type of backfill material used around buried raceways. The backfill material should be free of sharp objects, rocks, and other debris that could damage the raceway. It should also be properly compacted to provide adequate support and prevent settling. The NEC also addresses the issue of underground installations under buildings. Section 300.11c specifically prohibits the installation of raceways in or under concrete slabs unless they are encased in concrete or otherwise protected from physical damage. This requirement is intended to prevent damage to the raceways from settling or cracking of the slab. When installing raceways under a building, it is essential to ensure that they are properly supported and protected from physical damage. This may involve encasing the raceways in concrete, using a suitable type of raceway, or providing additional support. In addition to the NEC requirements, local codes and regulations may also apply. It is essential to consult with the local AHA to determine any additional requirements that may be in effect. The AHA is responsible for enforcing the NEC and other applicable codes and regulations. They can provide guidance on specific requirements and interpretations. When dealing with electrical inspections, it is essential to understand the role of the inspector. The electrical inspector is responsible for verifying that electrical installations meet the requirements of the NEC and other applicable codes and regulations. They will typically conduct a visual inspection of the installation and may also perform tests to verify its safety and functionality. If the inspector finds any violations, they will issue a notice of violation, or NOV, which must be corrected before the installation can be approved. In the event that an inspection is missed or a violation is discovered after the installation has been completed, it is essential to take prompt corrective action. This may involve contacting the AHJ, submitting a request for inspection, or hiring a third-party inspector. The goal is to resolve the issue as quickly and efficiently as possible to ensure the safety of the electrical system. When dealing with electrical installations, it is always best to err on the side of caution. If there is any doubt about the applicable requirements or the proper installation methods, consult with a qualified electrician or electrical engineer. They can provide guidance and assistance to ensure that the installation meets all applicable codes and regulations. Remember that electrical safety is paramount. Improperly installed electrical systems can pose a serious risk of fire, electric shock, and other hazards. By following the NEC and other applicable codes and regulations, and by working with qualified professionals, it is possible to ensure the safety and reliability of electrical installations. In addition to the specific requirements of the NEC, there are also several general principles of electrical safety that should be followed. These principles include always de-energizing circuits before working on them, using appropriate personal protective equipment, or PPE, and following proper lockout/tagout procedures. Always de-energize circuits before working on them. This is the most important safety precaution that can be taken. Before working on any electrical circuit, always turn off the power at the circuit breaker or disconnect switch. Verify that the circuit is de-energized using a voltage tester before touching any wires or components. Use appropriate personal protective equipment or PPE. When working on electrical circuits, it is essential to use appropriate PPE to protect yourself from electric shock and other hazards. This may include safety glasses, rubber gloves, and insulated tools. Follow proper lockout/tagout procedures. Lockout/tagout procedures are used to prevent accidental energization of circuits while they are being worked on. These procedures involve placing a lock and tag on the circuit breaker or disconnect switch to indicate that the circuit is being worked on and should not be energized. When dealing with buried conduits, it is also important to consider the potential for corrosion. Corrosion can damage the conduits and lead to electrical failures. To prevent corrosion, it is essential to use conduits that are suitable for the environment in which they are installed. For example, PVC conduit is resistant to corrosion and is often used in underground installations. It is also important to properly seal the conduits to prevent moisture from entering. Moisture can accelerate corrosion and lead to premature failure of the conduits. In addition to corrosion, buried conduits can also be damaged by physical forces. These forces can include soil movement, frost heave, and accidental digging. To protect the conduits from physical damage, it is essential to provide adequate cover and support. The cover should be sufficient to protect the conduits from damage from surface loads, such as vehicles. The support should be adequate to prevent the conduits from sagging or shifting. When dealing with electrical installations, it is important to keep accurate records. These records should include the location of all conduits, the type of materials used, and any other relevant information. These records will be helpful for future maintenance and troubleshooting. They will also be helpful if any problems arise with the installation. In the specific situation described, where the pipes were backfilled before inspection, several factors should be considered. The type of raceway used is important. If PVC conduit was used, it is less likely to be damaged by soil movement or corrosion. However, if metal conduit was used, it is more susceptible to corrosion. The depth of burial is also important. If the conduits were buried at the proper depth, they are less likely to be damaged by surface loads. However, if they were buried too shallow, they are more vulnerable to damage. The type of backfill material used is also important. If the backfill material was free of sharp objects and properly compacted, it is less likely to damage the conduits. However, if the backfill material contained sharp objects or was not properly compacted, it could damage the conduits. In light of these factors, it is essential to conduct a thorough inspection of the installation. This inspection should include a visual inspection of the conduits and a review of the installation records. If any problems are found, they should be corrected immediately. In addition to the specific issues discussed above, there are also several general considerations to keep in mind when dealing with electrical installations. Always follow the manufacturer's instructions when installing electrical equipment. Use only approved materials and equipment. Make sure that all connections are tight and secure. Protect electrical equipment from moisture and physical damage. Keep electrical equipment clean and free of dust and debris. In summary, addressing the issue of non-metallic raceways buried under a building without proper inspection requires a multifaceted approach. Contacting the AHJ, requesting a variance, submitting an RFI, hiring a third-party inspector, and using NDT methods are all viable options. Implementing mitigation measures, such as documenting the situation, protecting the conduits, and monitoring the system, is crucial for long-term reliability. Effective communication, professionalism, and a commitment to learning from mistakes are essential for resolving the issue and preventing future occurrences. By following these steps and adhering to the NEC and other applicable codes and regulations, it is possible to ensure the safety and reliability of electrical installations.